Hi there, I'm excited to demo for you today the new version of Transformer Lab that's designed for teams. If you work at a research lab and work across multiple GPUs, we want to be the main interface that researchers use to submit their tasks and view the results of their experiments. Let me show you a quick demo of what that can look like. The first thing that you want to do when using Transformer Lab is connect it to the providers that you use to orchestrate your GPUs. In this example, I have Slurm running on AWS, and I've connected Transformer Lab to that. And I'm also using SkyPilot to control the machines that are behind me, and I have a separate connection to that. Now Transformer Lab has access to the compute that you have across your entire team. Now, as a researcher, the first thing that I want to be able to do is experiment a little bit without having to run a task. Here I can use something called Interact, which will reserve a machine for me where I can run tasks through a Jupyter notebook or have direct SSH access or run VS Code, and the computer will be held for me until I return it back to the system. This is really good if you want to run inference, for example. So if you wanted to run VLLM or Ollama and you want to keep that machine up and running, or if you just wanted to experiment and hold on to a machine until you're ready to release it. But the main way that your researchers will want to use Transformer Lab is to submit tasks that go into a queue that use the available GPU that you have access to. We can start in this example with one of the tasks we have in the example gallery. Your team can create your own team-specific tasks that are used as examples for the organization and starting points for a new experiment. Today, I want to try fine-tuning an LLM using Unsloth, so I'll import an example script using that recipe. Now that it's available to me, I can edit the task YAML to specify exactly how I want it to run on the compute that I have. Here it's saying that I want 2 CPUs and 4 GB of memory, and I want the machine to have at least one RTX 3090 on it. The actual command that's being run is over here, but before that's run, a setup script is run that's over here. Now, if I press Q, the system will go and try to find compute that satisfies the requirements of the task that I've just created, and then it'll provision the machines and run the task in the cloud. Those machines could be anywhere, but the artifacts that are created get persisted in a global store. I ran this job a little bit earlier, so you can see what the artifacts look like once you've completed a job. Here, if I click on weights and biases, you can see the loss function and other metrics related to the train. If I click on output, I can see the actual output that came from the specific print functions inside the train. I can also see checkpoints that were generated during the train process, and I can restart a train from one of those checkpoints. And I can see all the artifacts if I click on the Artifacts tab. That's a quick tour of interaction and training inside Transformer Lab.